Good morning. I hope you had a wonderful weekend. Had some beautiful weather. Hope you got outside, stayed away from people, but got outside, played, enjoyed the beautiful weather. But before we get started, I wanted to share just a quick tip. If your IXL is not working, what you will need to do is you will need to go into the app portal, find IXL, click on it, and click the install button. That will actually update the app. Even if you already have IXL, you still need to click install so that the app will update. And then once it updates, you're going to be able to do IXL today. Now, for the one that crashed on you guys last week, I know some of you had some issues when IXL was in and out. I'm going to forgive that one. Okay, so if you didn't get that one all the way done, that's okay. I'm going to need to at least see that you made progress on that. But for today's, if it's not working, you're going to need to follow the steps that I just told you to do. Go to the app portal, find IXL, click on it, and then click install. All right, let's get started with today's lesson. Today we're going to be talking about angles and how they relate to each other. And then we're also going to be doing a little bit of real-world activity with these, which I think has some pretty neat information in there. So we're going to be on lesson 8.2. So if you want to pause your video and open your math journals to page 8.2 or lesson 8.2, you can. But we're going to be skipping 8.1. We're just going to be doing a few lessons here and there to finish out the year. But today we're going to start with angles. Now, if I said, draw me an angle you know, like you know for sure that the angle you're drawing is that size, I know many of you would probably choose a right angle because you know that that one is 90 degrees. Okay, what would be another angle that you know for sure? Anybody? Raise your hand if you know. No? Okay, well, then I think we could also remember that, we did straight angles, and those were 180 degrees. And then there's one more that we know for sure, we can draw, and that is, what is this? Well, if you draw the arc, that is a 360 degree angle, which we would call a full circle, full turn. Okay, now the reason I said draw one that you know, because if I said, hey, draw a 47 degree angle, 47, I mean, I could probably estimate that, right? I could probably say, okay, it's got to be less than 90, so it's got to be less than a right angle. So maybe like this, if I'm guessing, 47 degrees maybe. But we don't know for sure, and that's the problem. And so we can't use angles that we don't know for sure for today. So we're going to be using our right angles, our straight angles, and our 360 degree angles. What we're going to be doing is we're going to be using those to help us solve missing angles. So let's look at our first page on lesson 8.2. We're going to be finding the missing angles, and then we're going to write the equation and tell how we got it. Okay, so if we look at number 1, it looks like there's a sprinkler, so we have our lawn here, and then the sprinkler is shooting at a 65 degree, and they want to find out what the measure of that angle C is. Well, which angle do you see for sure that you know the exact measurement of? Well, I see a 65, and I also see this straight angle, which is 180 degrees. So if I wanted to find out what C was, well, if 65 and that C make the 180, then I know that whatever 180 minus 65 is going to give me C. And that's my equation. So 180 minus 65 equals C. Could I write this equation another way? Again, does anybody know? Raise your hand if you do. Nobody did. Okay, we're probably still asleep. Another way to write this is to do 65 plus C equals 180. Okay. Oh, you knew how to do that? Good. Okay, I just didn't see your hand. All right, so that would be another way how to do it. All right, so now we just have to figure this out. So let's go back up here to our subtraction problem. What is 180 minus 65? 0 minus 5 you can't do. Technically you can, but we need to regroup it if we're going to subtract it like this. So that becomes 7. The 0 becomes 10. 10 minus 5 is 5. 7 minus 6 is 1. And then I bring down my 1 for 115 degrees. Now, does that look like a 115 degree angle? Does it look obtuse, angle C, right here? I would say yes, it does. And so that is an answer that makes sense. If you get an answer of, let's say you got 15 for this, you would know that that's wrong because angle C is obtuse, which means it has to be greater than 90. Okay, let's look at number 2. All right, on number 2, it looks like a skateboarder, and he's doing some sort of skateboard trick. Skateboarding is not my specialty. All right, so it says from this spot here over to this line is 270 degrees. They want us to figure out what S is. So we're going to take what we know of the 270 plus whatever S is, and that's going to give us our unknown. 270 plus S equals, oh, wait a second. What do those two angles make together? Think back to our angles that we know. Does it make a right angle? No. A straight angle? No, it makes a full turn, so 360. So if I look back here, the 270 plus the S makes 360, and that's going to be our equation. So to find out what we need, or to find out the answer to that, I'm simply going to go 360 minus 270, and that's going to give me my answer. 0 minus 0 is 0. 6 minus 7, let's regroup. That becomes 2, this becomes 16. 16 minus 7 is 9. Oh, 90 degrees. Does that look like a right angle right there? It does. So if I would have just paid attention, I would have known that that probably was a 90-degree angle. Or if it looks like 1/4 of a full turn, it's because it is 1/4. Good. All right. I want you to pause this video, and I want you to try numbers 3, 4, 5, and 6. All right, for number 3, you should have gotten 160 plus R is 180, or 180 minus 160 equals R. And you should have had 20 as your answer. Next one, we should have had 270 plus P equals a full turn 360, which is exactly what we did on number 2. So that one is a 90-degree angle. Number 5. By the way, don't sit like that in your chair. You're going to have bad posture. You're going to be in a lot of trouble if you sit like that. I see that 65 and C, 65 plus C, if I put those together, that makes a right angle right there. So that's 90. So when you do that, you get 25. 65 plus 25 is 90. Last one, doing leg lifts. Make sure those lower abs are strong. Take the 45 we know plus I or L. It's a bad letter to choose because it looks like 1. 45 plus L equals 90. It makes a right angle right down there on the floor. So 45 plus what is 90? That is 45. All right. So let's take it a little bit further, and we're just going to do a few of these. But this is talking about your field of vision. So if you look at, for example, an animal is the human, the first animal. We as humans have a 180-degree field of vision. So if you look straight ahead, and you look your eyes to the left, look your eyes to the right, you can only see about 180 degrees. A good way to test this is if you hold your hands out to your side, as far as you can to the right and to the left, and look to your right, look to your left. You can just about see your hands, and that's about it to make the 180. So they want to know, what is our blind area? Blind area. What can you not see? All right, well, let's look at the human. The human can see 180. The blind area would be back here, where they can't see. If someone's coming behind you, you can't see that unless you turn your head. So if I'm looking at this, 180 plus, let's call this x because we don't know it, is going to equal what? Well, 360. It's going to give us our full circle, full turn, full field of vision. So how do you figure that out? Well, I know that I'm going to subtract. So 360 minus 180. 0 minus 0 is 0. 6 minus 8. Let's regroup. So that becomes 2. This is 16. 16 minus 8 is 8. And 2 minus 1 is 1. So that means we have a field of vision of 180 degrees, but a blind area of also 180 degrees. So we can see exactly as much as we can't see. Now, if you look at a fox can see 260 degrees. Okay, so 260 degrees. Now, if we think about what they can't see, think about what 260 would look like. It would look something like this area here. So a fox could see all the way from where my arrow starts, where my arc starts, all the way to the end. So we need to figure out what they can't see right here. Okay, well, if this is 260, how are we going to figure out what they can't see? Well, I know that the full circle right here, this full field of vision, is 360 degrees. And since they can see 260, we go 360 minus 260. And that means we're going to get 100. All right, what I want you to do is I want you to try the next few that I highlight. Try the horse, the cat, the dog, and the owl, please. Pause this video, and then I want you to try it on your own. All right, for the horse, you should have gotten 3. Only 3 degrees that it cannot see, meaning 357 degrees it can see, and only a little bit behind itself which it can't see, which is probably why you get kicked when they can't see you, because they get scared. They can see a lot. Now, if you notice, the blind area of a cat is 160, so you have to figure out what they can see. So it's 160 plus, it's a time symbol, plus what is going to give you the full field of vision, which is 360. Okay, so 160 plus what? You should have gotten 200 for that. Okay, same thing for a dog. We're going 120 plus what is 360? And that would be 240. Good. Now an owl is 110 that it can see. So what can it not see? You should have gotten 250. Now I find that kind of interesting that the owl, for the ones that we tried, was the one who could see the least. But for those of you who know a little bit about owls, the special thing about owls is that they can turn their head almost all the way around. So even though they can't see very far, or very wide would be a better way to say that, they can turn their heads so that they make that up. So it's interesting how animals have those adaptations to help them survive. Okay? All right, do me a favor, guys. Go ahead and log into IXL and find the IXL you need to complete for today. Thank you.